Hey guys, how are you? Welcome back to the channel. Today is day 25 of Upskilling myself, and today I just solved 3 DSA problems, and those were mostly easy ones because I had some internship work to do. I had to do the testing part of the front end and back end together, so it took a lot of time. So, yeah. So, the first problem is counting bits. So, we have been given a number, let's say 2, and we have to return an array which consists the number of bits of every iteration of it. So, let's say from 0 to 2, we have to give the total number of ones in the bits. Okay, so for 0 it's 0, so we add 0. For 1 it's 1, so we push 1. For number 2 it's 1, so we push 1, right? So to solve it, we create an answer vector, then we traverse the whole number from 0 to n, right? So if I is equals to 0, we directly push back 0 and we continue, and we set the count as 0 if I is not equals to 0, and we set the number as the ith index, and while the number is not equals to 0, we increment the count as the number and 1. So the least significant digit, which is let's say if it's 0 and we add it with 1, we'll get 0. So nothing will be added in the count, and if it's 1 and 1, then we'll get 1, and which is incremented in the count. Then we right shift the number to get the next bit, and then we push back the count. So next problem was reverse bits. So we have been given an integer, let's say this. So we have to output this integer, and it's the exact reverse of the bits of the first integer, as you can see over here. So to solve it, what we do is we get the bit from the number using AND, then we add the number to the least significant place. And so to solve it, we do the left shift of the number, then we do OR with the bit that we have. Okay. So we set result as 0, then we traverse from 0 to 32 as we have 32 bits over here. Then we get the current bit by doing AND, then we right shift the number, and then we store it in the result as result is left shifted. So if you see, when we do right shift, we get in this format, and we have to store it in reverse, right? So we'll left shift to add numbers in the most significant manner. Okay, and then we return the result. So the final problem was bitwise AND of number range. So we have been given a range, let's say for example 5 to 7. So we have to AND all the numbers in this range and give the output. Okay, so one way could be just go from 5 to 7 and do 5 and 6 and 7, but it would be like of more complexity, and we don't want it. We want to do it using the bitwise operations. Okay, so what we can do is we first create an integer shift which is equals to 0. So we will keep a note of how many times we have to shift the number. So while left is not equals to right, which is left is less than right, we right shift left by 1 and right shift right by 1. Okay, then we also keep a count of shift, and then after left is equals to right, then we shift left by the number of shifts. So let's say if 5 is 101 in bits, 7 is 111, then unless until we get the most significant equal place, which is this one, yeah, we will left shift it. So on the first shift it will be 1 0 1 1, they are not equal. On the second shift it would be 1 and 1, now they are equal. The shift is incremented to 2 and the left is 1. Okay, so now the left is 1, we will left shift it by the number of shift, that is 2. So it will be 1 0 0, which is 4, which is the output. Okay, so for the development part, I did my internship work. I had to test the front end and back end together. Then I recorded some YouTube videos and did the revision of all the DSA problems that I solved till now. So thank you guys for watching. See you on day 26.